presenter is Jack Lynn.
Quantum mechanics. What do you think of when you hear these two words? Is it of something mysterious, only understood by a few? What many people do not know is that they use the world of quantum mechanics every day. When you send a text, check the news, or watch TV, you are harnessing the power of the quantum world. Today, I'll explain 3 of the key principles of quantum mechanics which can be used to improve New Zealand. First, what is quantum mechanics, and what makes it different from classical physics? Classical physics governs the logical world that we experience every day. For example, why an apple falls off a tree. In classical physics, it is possible to know both the position as well as the velocity of an object. Quantum mechanics governs a much weirder part of physics. In quantum mechanics, the more accurately the position of an object is known, the less accurately its velocity is known, and vice versa. The first principle I will explain is the photoelectric effect. The photoelectric effect is the interaction between the photons in light and the electrons in metal to produce electricity. The photoelectric effect occurs when a photon of an energy equal to or higher than that of the threshold energy level strikes a piece of metal, releasing an electron. If this electron is collected and the piece of metal is part of a circuit, a current will be generated. The photoelectric effect is important if New Zealand wants to substantially increase its electrical production. Solar technology could do this, though existing solar panels only have a single threshold energy level. This means that photons with an energy level lower or higher than that of the threshold are wasted, because they cannot knock an electron off or the extra energy is lost. Existing solar technology is inefficient, as it only converts 30% of the sun's energy into electrical power. Also, if the threshold energy is lowered, then the voltage is lowered. Technological advances, such as quantum dots, are eliminating many of these inefficiencies. Quantum dots are tiny semiconductors within which the threshold energy level can be changed by adjusting the size of the quantum dot. Using the quantum dots as the material for solar panels would allow the production of panels with a large variety of threshold energy levels. This means that more photons can be captured and all the energy and high energy photons can be converted, increasing the current. Using quantum dots to make solar panels would at minimum double the energy conversion from sunlight to electricity compared with existing solar panels. The next principle I'll explain was made famous in the 1935 analogy by Erwin Schrödinger. In this analogy, Schrödinger's cat is placed in a box with a vial of poison gas. The vial has a random chance of breaking, killing the cat. When the lid is on the box, we do not know the state of the cat. The cat could be dead or alive. When something is in multiple states at the same time, it is called superposition. Under superposition, when the lid is on the box, the cat is both dead and alive at the same time. It's only by opening the box, observing the cat, and breaking the superposition that we discover if the cat is dead or alive. The principle of superposition is being used to build quantum computers. Existing computers contain transistors that can be in the on or off position. This is the base architecture of all computers, namely zeros and ones, which are called bits. If you apply superposition to a bit, you get a qubit. A qubit can be a 0, a 1, or a bit of both. A way to think about this is to imagine that you're sitting at the centre of the Earth. If you're a bit from an existing computer, you can point to the North Pole, a 0, or to the South Pole, a 1. If you're a qubit, you can point anywhere in the world and make a mixture of zeros and ones. Due to the ability to be zeros and ones, quantum computers can check multiple solutions at the same time, which makes them significantly more powerful than regular bits. This power is shown in a quantum computer's ability to solve hard problems such as the travelling salesman problem. An example of how quantum computers can be used to positively assist our country's future is in the potential impact on weather forecasting and how this could be used to increase crop production. The weather is an incredibly difficult thing to predict on an existing computer as there are so many variables. With a quantum computer that, due to superposition, is very good at handling large amounts of variables, you could accurately predict the weather. This has a very significant impact on crop production. Entanglement is the final principle of quantum mechanics that I'll explain, and it is also one of the weirdest. When it was first proposed in the 1930s, Einstein called it spooky action at a distance. The easiest way to think about entanglement is to imagine two spinners, each half blue and half red. If you entangle these spinners and spun them, if the first spinner lands on blue, the second spinner must land on red. It does not matter how far apart the two spinners are. Entanglement could be significant to commerce, as the key to any financial transaction is communication, and with entanglement you could build a truly instantaneous network. A network built with entanglement will also be incredibly secure, as there is no wireless, digital, or optical transmission that can be intercepted. Investing in quantum mechanics and quantum technologies will also stimulate our education sector. With more money being spent on science and technology, it will encourage our scientists, engineers, and mathematicians to stay in New Zealand and stop the brain drain to other countries. Keeping New Zealand's brightest means that we, as a country, profit from any discoveries that are made. Many of the great revolutions of the modern world were due to a new understanding in science. Now there is about to be a new quantum revolution, and New Zealand could be the leader in that technology. With quantum mechanics, we can build a better future and a better New Zealand. Thank you.